horrible, horrible math in this case.
You get a new sheet every time
What?
when you do it. Like when you write on it, you get a new packet.
Just because otherwise you can see my writing through there and it starts getting messy. Like I kept, so I'll do the front side of this one and then I'll get a new packet and then I'll keep this one from the first packet. When I make copies, I always make myself 2 extra. One, just in case one of you are like, can I just have a new copy? Like, because you're mad at your own self for something. And the other so that I can use 2 different copies to make mine. All right, the results of a state mathematics test for random samples of students taught by 2 different teachers at the same school are shown on the left. It certainly is not. So let me get my stuff. All right, so teacher 1. The X bar for teacher 1 was 473. The S1 is 39.7 and the N1 is 8. For teacher 2, the X bar 2 is 459. The S2 is 24.5 and the N2 is 18. Data that should have been in the problem. Okay. The results of a state mathematics test for random samples of students taught by 2 different teachers are shown at the left. What are you seeing when you look at these 2 teachers?
One has much more students.
Mm-hmm. One is teaching 18 students, one is teaching 8. That's true. What else?
A teacher teaching 8 students has a higher variance and a higher average test score.
What does it mean if it has a higher, well, higher test score average means that on average they're doing better, right? What does a higher variance mean in this case?
Less consistent.
Maybe you got a lot of lows and a lot of highs. You got very inconsistent students, okay? But on average, higher than the other class, yep.
So the S is the standard deviation
Yes,
for a sample.
for the sample, so S1 is the standard deviation for these 8 kids. And S2 is the standard deviation for these 18 kids in 2 different classes.
So we don't know it because it's for a sample.
Right, this is a sample standard deviation. But it's not, but we do not know, because they specifically wrote S here, and they did not write population standard deviation, the words or the symbol, we assume that this is a t-test. So that's how I would begin this if I was doing this. I would think about this chart, and I would think, okay, we're not doing Z, we're doing a T. Are the population standard deviation known? Now the 2 different formulas, the only differences between the 2 is are the variances equal or are the variances not equal? Remember, variances equal is pooled, that's just a language thing, and variances are not equal is not pooled. So when you look at this problem, do you see that the population variances are equal or not equal? Not equal. I mean, it says it right there. It is not one of those hidden things that you really have to figure out. Like, it'll say directly which one it is. All right, so is this going to be the horrible formula or the not so bad formula?
Not so bad for
The not so bad formula. Great news. Okay. You know that the next one is going to, did everybody look and see if the next one was? The next one's going to be horrible. H sub O, H sub A. It says, can you conclude that there's a difference? So their claim must be that there's a difference. So what does that mean? Equal to and not equal to, but and the claim would be the not equal to. So mu sub 1 is equal to mu sub 2, and mu sub 1 is not equal to mu sub 2. P.S. The ones for proportion and for paired tests are a lot easier. This is the hardest formulas in this chapter, is today. This is the claim. Left, right, or two-tailed? Do you guys want to use p-values or rejection regions? Me too. I like them better too. All right, you guys know we need our t-chart, right? So you got your t-chart out? is mine? I keep using mine for other things.
What other things do you use it? Like teaching your friend.
I'm teaching my friends now. I'm using mine like I'll be making a key for something or working through something I'm going to teach, and then bring it home and leave it there. Okay. We're just leaving it? Okay.
I'll grab this out first, so I can put them all the way together.
Okay. So we're looking at this two tails, right? Do you remember me saying that we need to look at the degree of freedom? And this will say this actually says this as well on the formula sheet, what the degree of freedom is. So the degree of freedom in this case is which one's smaller? N sub 1 minus 1 or N sub 2 minus 1?
That's a 1 minus 1.
Yeah, so 7. Is everybody understanding that? So we're looking at, because 8's the smallest one, minus 1. And what was this? This is a 10%, but it'd be 10% on one side, 5% on two sides, right? So it should actually be two-tailed, this one, 1.895, yeah? Negative 1.895 and positive 1.895. Okay, now we see if we can do this in our calculator. And not like as in the calculator does it for us, but as in like we're gonna try to actually put in this formula and see if it works. Okay, let's write it out first, yeah. All right, so the top is 473 minus 459. And the bottom is a square root. And then 39.7 squared over 8. And 24.5 squared over 18.
Isn't this like exactly like the other one we did?
Exactly like the other one. It is exactly like the other one we did. Unless it's pooled, it's exactly the same except for that it's a T instead of a Z. All right, put it in your calculator. It was really interesting though when my friend started asking about p-values because she literally like pulls up on her phone. She's like, do you want to see the p-values for success in lung transplants from 6 months and 18 months? And I was like, yeah, I guess I do. And like, it's really kind of fun data. And I was like, can I use this for my class? She's like, this is confidential and I shouldn't even be showing you. And I'm like, got it. Yeah, okay. So no, don't show my class. Did you get 0.92?
Yep.
Make sure we're doing this right. Yes, we are.
How come, like on the last, like on 8.1, it went like past, it was like 1.922, let's say.
Hmm.
Why did they go past? Like, cause like on the Copper's intervals on here, it was like 1.96, but then the answer they got was like 3 digits past. Why did they,
Why did they what?
like instead of going 2 digits to the 100th, they went to the 1000th?
Oh, I see what you're saying. Because on this, I don't know, this table is just all to the 3 digits, but usually they only go to the 3 digits if it's halfway between two things with Z tables, and I really don't have a good reason for that. It seems to just be tradition. Not tradition as in like, you know, my grandfather's grandfather did 3 digits, so should I, but I've just always seen it done that way. Okay, so here we got 0.92. Falls